Alright, so this is section 7.1, which is on correlation. So a correlation is between two random variables. So x and y, we say x and y are bivariate random variables. Bivariate means x and y might be correlated, might not, but we don't know yet. And rho, xy, is the population correlation between x and y. But usually we don't know the population values because we don't have all the data in x and y. So instead we collect samples. So we have bivariate samples. x1, y1, x2, y2, all the way to xn, yn. So we have n samples. Then rxy is called the sample correlation coefficient between x and y. Okay, so the formula for r is there are three ways to calculate r. They're all equivalent. It'll give you the same answer. It's 1 over n minus 1. n minus 1 because it's sample. Sum I from 1 to n xi minus x bar over the sample standard deviation of x times yi minus y bar over the sample standard deviation of y. So that's one way to calculate it. The second way to calculate it is plugging the formula for sample standard deviations. Then we get a big fraction. The numerator is the sum of xi minus x bar times yi minus y bar. And the denominator is the square root of the sum of xi minus x bar squared times the square root of sum of yi minus y bar squared. That's the second way to calculate it. And there's the third way to calculate it. If we do some algebra, this is equal to the sum of from I equal to 1 to n xi yi minus n times x bar y bar. So that part is not part of the sum. And the square root of the sum of squares minus n times the square of the sample mean. Same with y. This is y. Okay, so this third method is usually preferred because it's easiest to calculate. Same with standard deviation. The last formula is always preferred. So let's do some examples. Okay, so let's keep that formula on top so we can actually use it. Okay, let's do some examples. Okay, so suppose xi, we have sample of 5 data. xi is 1, 2, 3, 4, 5, and yi is also 1, 2, 3, 4, 5 to make it easiest. So y is literally the same as xi. So we need to calculate a few things. We need to calculate x bar, y bar, which is not hard to calculate. The x bar is the sum 1 plus 2 plus 3 plus 4 plus 5 is 15 divided by 5, which is 3. Y bar is also 3. And we also need to calculate the sum of squares. So sum of xi squared is 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. 25, 50, 55. And it's the same as the sum of yi squared because, again, they're the same thing. And the sum of xi yi is 1 times 1, 1 squared, plus 2 times 2, 2 squared. So it's literally the same thing again. Also 55. Alright, I think we have enough to calculate the sample correlation coefficient. So let's plug in the formula. So in the numerator, we have the sum of xi yi, which is 55, minus n, which is 5, times x bar y bar, which is 3 and 3. In the denominator, we have the square root sum of xi squared, that's 55, minus 5 times x bar squared, that's 3 squared, and square root of sum of yi squared, that's also 55, and minus 5 times y bar, which is 3 squared. So this is equal to 9, this is 10 over square root of 10 times square root of 10, which is literally equal to 1. So instead of calling this 1, we call this 100%, means xi, yi are 100% correlated, which makes sense because yi is literally equal to xi. So it makes sense that xi and yi are 100% correlated. Okay, so let's permute the example a little bit. So xi is still 1, 2, 3, 4, 5, but yi this time is 5, 4, 3, 2, 1. Okay, so what's the same? X bar is literally the same, still 3. Y bar is still 3 because the yi's are the same set, so y bar is still 3. The sum of xi squared is still 55. Sum of yi squared is still 55. But what changes is the sum of xi, yi. This number is different because the order is different. So this is 1 times 5 plus 2 times 4 plus 3 times 3 plus 4 times 2, 2 plus 5 times 1. So that's 16 plus 9, 25, 35. So the sample correlation coefficient is equal to 35 minus 5 times 3 times 3, and the denominators are the same, so it's still 55 minus 5 times 3 squared. So this is equal to negative 10 over root 10 times root 10, which is negative 1. Instead of writing negative 1, we write negative 100%. So this is saying that xi and yi are negative 100% correlated. And this makes sense because you can see the pattern as xi goes up, as I goes up by 1, yi predictably goes down by 1. So because yi is 5 minus xi. Okay, so let's do a slightly different example just to see what happens. So let's take the 1, 2, 3, 4, 5 example. Okay, but let's permute the 2 and 4. So now it's yi's are 1, 4, 3, 2, 5. See what happens. So now x and y are not 100% positively correlated anymore. So x bar is still 3, y bar is still 3 because this is permuting the things. Same with the sum of squares. 55, sum of y squared is 55. Sum of xi, yi is 1 times 1 plus 2 times 4 plus 3 times 3 plus 4 times 2 plus 5 times 5. 25 plus 8, 33, 42, 51. Yep, 51. So R equals to 51 minus 5 times 3 times 3 over square root of the same thing. Square root of 55 minus 5 times 3 squared times 3 squared. So this is equal to that's 6 over root 10 times root 10, which is 0.6, which is 60%. So this means xi and yi are positively 60% correlated. Right.